right, I think we're ready here. So good morning. For those of you who don't know me, my name is Kevin Myers. I'm a network architect with IP Architects. For those of you that don't know about our company, for about the last 3 years, we are a design, architecture, and engineering firm for MikroTik related solutions and integration. We do a lot of really large solutions with publicly traded companies, large data centers, large service providers. A lot of our companies, we've got a couple that are Fortune 500 companies, so we've been working to get MikroTik into some really unique places that maybe hasn't been before, hasn't been as prevalently. So we've been doing some really neat things in the last year. And one of the things that I wanted to share with you that we've been working on actually came out of a data center project. We had a large data center project moving between countries. We moved a whole data center from one country to another, and it actually kind of spurred this design concept that we wanted to talk to you about because we noticed that the CRS was capable of doing this task in lieu of the $100,000 Cisco switches that we put in to do that task. So we thought it was a pretty neat project. So a little bit about me. I'm a MT-CINE, privileged enough to trade with Andis last year to do that, and then recently got my MikroTik certified trainer, so I was really happy with that, and thank you to Giannis for that and all the classmates that are here for my MikroTik certified trainer course. A little bit of background on me. I've spent the last 17 years in IT, network engineering, and architecture. Do a lot of MikroTik integration with multi-vendor networks, Cisco, Juniper, F5, IBM, you name it. Design of BGP, MPLS, and OSPF service provider networks. Before I got into the data center, we did a lot with MPLS service providers, and we're putting MikroTiks out on Cisco MPLS networks as an MPLS endpoint, and that was a really, really popular thing. And then most recently, large enterprise data center networks. We definitely do a lot of work in that space. And then before I get started, I just want to tell you guys to come by our booth here in the MUM exhibition hall and tell you about IP Safenet. We've launched a product that is going to be kind of similar to Cisco's SmartNet, where instead of having to pay consultants for hourly support for MikroTik to learn about MikroTik and help you with MikroTik, you can actually buy a maintenance contract on your MikroTik hardware like SmartNet. And there's 3 different SLA tiers. It comes with hardware replacement. And you can open a ticket and escalate it through our 3 tiers of engineering to actually ask questions and have an interactive support experience with an engineer for MikroTik related products. And we've got 8x5 by 3 business days is the value tier, 8x5 by next business day, and then 24x7 by next business day. So if you really have a critical solution, and we do have some customers that have those solutions, you can actually have an engineer on the phone 24 hours a day, 7 days a week, assigned within as little as 4 hours. So, and that's something that, as far as we know, in talking to MikroTik, this is the first time this has been offered in the world in the MikroTik space. So we're pretty proud of that. And then if you come by our booth, we're offering a trial for it for 30 days. So if you've got a serial number of a piece of hardware that we're supporting in the first initial run of this, come on by and we'll sign you up and get you kind of a brief demo of what this will look like and what it'll feel like. And we'll be happy to talk to you about that. So let's talk about our topic for today, VLAN translation. Hopefully, when you get to the end of this, you're going to understand and learn what a VLAN translation is and what the different use cases are, what the different implementation types are for VLAN rewrites in RouterOS, and walk through some of the implementation examples that we use VLAN translations in a router as well as a CRS switch. So what is a VLAN translation? A VLAN translation or a rewrite, it basically involves taking a VLAN tag out of the Ethernet frame and rewriting it to a different tag. So if you look at the example here, we've got a CRS 125, which is what we built this on in the lab. And we're taking the same subnet, 10.1.1. It's 0 in this case, /24. And we're pinging between 2 hosts, both on the same subnet, but you notice the VLAN changes. And we're not actually routing here. We're actually changing that VLAN tag as it comes in that port and spitting it out a different VLAN tag. And we'll get into why would you do that here in just a slide or two. So if you look at the config, you can see there's a statement here in the CRS where it matches VLAN 101 coming in right over here in VLAN 101. And then right as it comes in, it rewrites it to VLAN 201, so it can make it down to this guy. And the neat thing about the CRS is because it's a switch, it can do this at wire speed. So you could do a VLAN rewrite at 1 gigabit in a CRS switch. And then conversely on the egress, as the packet has to make its way back through the switch, you do an egress rewrite, and you take and match anything coming from VLAN 201, and you're going to rewrite it to VLAN 101. And in that fashion, you can actually rewrite between the 2 VLANs. So a lot of people have asked me when we were talking about this, is this Q and Q? And it's actually not Q and Q. For those of you familiar with Q and Q is a technology in VLANs especially, where service providers will use it. You can actually nest a VLAN inside of another VLAN. So say you're a service provider and you have a customer that wants a layer 2 handoff, and their VLANs coincide with your VLANs. So you put them in another VLAN that's another header, and you transport it that way. This is something a little bit different. What this is actually taking in your 802.1q tagged frame, your VLAN tag, and as it comes into the switch, you take that tag and you replace it with a different tag. Now, what problem are we trying to solve? Why would we do this? How is this relevant? In merging companies, especially when larger companies will merge, there's often duplicate VLANs in campus switching and headquarters environments. So they may use one VLAN for one thing, company A. Company B uses the same VLAN for something else, but you're going to have an overlap there because they're probably two different subnets. So if you want to join a VLAN into a switching environment, you have to do a translation of it somehow so that you can keep everything straight. One of the big use cases, and the one that we did this year, was the data center interconnect, which was kind of a really neat thing. A lot of data centers globally are interconnected at layer 2, either over MPLS or over some dark fiber transit, something like that. And what will actually happen is if a data center has to get migrated to another data center and you have VLANs that overlap, and we'll look at a use case that kind of talks about what it looks like here in a second, you can actually rewrite that VLAN as it's in transit from one data center to another data center. And then, of course, service providers. Whether you're a wireline service provider or you're a WISP service provider, you know, a lot of people will use VPLS to backhaul layer 2. You may do it for PPPoE, things like that. You may have an acquisition of another WISP, or if you're a wireline, you may have an acquisition of another CLEC. And when you do that, you may have conflicting VLANs as you're backhauling things for PPPoE and decide that you need to rewrite those tags to bring them into your switched infrastructure. So for the example here, we're going to look at a data center interconnect. And we're going to take VLAN here out of a data center in New York. And VLAN 101 needs to go to the data center in Denver, Colorado. And it's for web servers on 10.1.1.0.24. Unfortunately, the data center in Denver uses VLAN 101 for something else. They use it for storage replication on 192.168.22.0/24. It's a completely different subnet, completely different purpose. But somehow, we've got to get VLAN 101 into the data center. So the solution there is we take VLAN 101 and we rewrite it as it makes its way to Denver into VLAN 201. And then it can live in Denver and translate back and forth as it crosses the data centers and keep all of that traffic separate. In the RouterBoard world, you can do this either via bridging or you can do it via CRS. And we'll look at the use cases of both of those, and we'll look at kind of the pros and cons of when would you bridge it, when would you switch it. So here's our data center example, VLAN 101. You can see here I am in New York with my VLAN 101 subnet coming into my switch, and here's my edge switch that's interconnecting these data centers. And I'm going to take VLAN 101 and it's going to come through this cloud here. It may be Metro Ethernet, dark fiber, VPLS, doesn't really matter. As long as it'll take a layer 2 tag, we're going to send it to this data center. But right here at this guy, which could be a CRS 125, we're going to do a VLAN rewrite so that this subnet can make it all the way at layer 2 to this other data center in Denver, and it can coexist with that VLAN 101 that already lives there that's for storage replication, and never the two shall meet. So, talking about the relevance of this, some questions come up when you're talking about this, because a lot of times when we talk about this, routing questions come up. You know, is this routing? Are you not routing between the two VLANs? And you're really not, because it exists at layer 2. So some of the questions that come up are about the broadcast domain. And it'd be helpful to cover what is a broadcast domain. If you've not worked with them, a broadcast domain is simply a logical subdivision of a network in which hosts can reach each other via broadcast. So in Ethernet, that's via MACs. You know, you have a MAC of all Fs, and you're going to do a broadcast, and you can reach any other host. So in this case, that's what the broadcast domain is. It lives at layer 2 of the OSI model. And why would this be important when we're rewriting VLANs? It's important because what you're doing is you're extending a broadcast domain from one network realm to another. And it may be as short as across your data center or your rack or your closet. And it may be as long as extending data centers around the world. And it doesn't really matter if you have a use case that you need to do this. You just need to make sure that you understand that you're extending this broadcast domain and what you're doing with it. So let's look at another use case. One that we've seen before is, what if you're a WISP? How could I use this if I'm a WISP? Well, in the WISP world, WISPs are being bought and sold, and that happens pretty frequently. And what if you have two WISPs that both use PPPoE to backhaul all of their, or VPLS to backhaul all their PPPoE traffic? That's a layer 2 backhaul. And you bring it all in here, and as you're consolidating your WISPs, so maybe it's the neighboring county. There's a WISP that you bought in the neighboring county, and you've decided that you've got a bigger rack, you've got more space to put things in your data center or your closet and your core, and you want to put all your BRAS, PPPoE termination servers in your core, not use theirs. Well, you may run into a problem if they're using the same VLANs backhauling, and so if they happen to use VLAN 777 and you use VLAN 777, you can put a CRS as you're backhauling that whole WISP network, that tower network in right here, and rewrite to 3777. So as you can see in this network over here, this is a completely different subnet that exists in the existing WISP. And you've got this other one that's the same VLAN tag coming from the WISP you bought, and you can keep them separate here. So, and that's not where it stops. I mean, obviously there's a lot of things you could do with this. These are just some of the use cases. So what we're going to do is look at a little lab scenario that we did. We actually did this in the Train the Trainer and work through this lab. I put all the components in here so you can kind of see how we step through this, and then you can get a CRS and actually do this yourself if you're interested. So the only things you really need are a couple router boards. You're going to need a couple laptops with Ethernet ports, 4 Ethernet cables, and then a CRS switch. And you can use the 125. I think if I remember right, all the CRSs will do this feature, so any of the CRSs will work for this. And this is kind of what our topology looks like. This is what we set up. We've got a lab in Jackson, Mississippi, where our architectural office is that we interconnect all kinds of things. We've got full racks of MikroTiks, AdTrans, Cisco, Juniper, data center. We have kind of a whole environment that we do interop testing with. And so we kind of built this little lab out to validate this use case. So we've got a couple maps here that we use to handle the VLAN tagging part. So we've got a VLAN tag of 101 going into Ether 1 here. And then it's untagged down to this laptop right here. And then we've got VLAN 201 going into ETH 2 and coming down to this map with a VLAN tag coming from the map north here and then south to the laptop. It's untagged. And you can notice it's exactly the same subnet here. So the objectives when you're doing this is to get it from VLAN 101 to 201. And we've already looked at our IP addressing for the laptop, so we can move on to step 1. So probably when I first did this, I had some issues. One of the things I've noticed, interestingly, with this, if you work with the CRS a lot, it is always a good idea to default it. I've noticed some strange things in the CRS, so defaulting it helped me get the VLAN rewrites working properly. And then you have to set your master slave up again and all that. The devices need to be connected according to the topology diagram, and go ahead and set your laptops up for your IP addressing, and make sure you turn off your firewalls. We hit that speed bump once when we were trying to ping across each other. And then here's your initial config. You could do this with 2 laptops. If you know how to VLAN tag in your laptop, you certainly could lose the maps and use your laptops directly. But a lot of laptops, it gets tricky to do the VLAN tag, so it was a little easier to actually get the maps to do that job for us. So if you've never done that on a MikroTik, you can actually build a VLAN interface on the MikroTik on both of these guys. There's 101 and 201. And then you put it into a bridge. And so if you want to take an untagged port and make it a tagged port, you literally just put the VLAN interface and the Ethernet port into a bridge, and then you'll pass from tagged to untagged. And you do this on both routers. So now we get to VLAN translations. And this is, and I typically show this in the CLI instead of Winbox. You can go do this in Winbox. It's a little bit easier to actually see what's happening when you look at the CLI, and that's what we tend to show them in our presentations. But the first statement here is actually a match statement. So even though it says customer VLAN ID, it's matching and looking for a tag. So traffic and in this case is ingress, it's trying to match VLAN 201, and then if it matches it, it's going to rewrite it with new customer VLAN ID of 101. Same thing here with this guy, and then it gets assigned to a port, Ether 2. Same thing with this guy. This guy is 101 matching, and then it's going to give it a new tag of 201 out Ether 1. Same thing on egress. So whatever you write on ingress, you have to do the same thing on egress so that your packets will make it back and forth. So you're going to match your VLAN 101 on this side into 201 is your rewrite for Ether 2, and same thing here for Ether 1. So our validation of the test, as we get through and we've hooked our lab up and we've done our configuration and got our rewrites running, is we can ping from one laptop over to another, and here we can reach both of those guys. And that's great, but what if you want to actually look at, how is this doing this? How can I validate that this is actually working? And this is how we validate it. If you've never done a packet capture in the CRS, an interesting thing I found is that because the ports are switched in hardware, when you do a packet capture, you're not going to see anything if you light up the sniffer in a CRS initially. What you actually have to do is go to a configuration called mirroring, port mirroring, and if any of you have worked with other vendor switches like Cisco or Juniper, you'll probably be familiar with the mirror concept. And what it does is it takes any traffic going in and out of a certain port that you select the mirror on, and it rewrites all of those frames into the CPU. And so what you can do then, and there's two CPU mirror ports. There's mirror 0 and mirror 1. I think you can only have 2. And then you can select on the port config, I want to mirror ingress on this port, and I want to mirror egress. And once you've done that, then you can actually extract packet captures from switched ports. And that's what we're going to look at here. So we've got our trusty Wireshark up here to see that we're pinging between these two hosts. And so we can see in the summary screen that we've got valid ICMP traffic. But the really unique thing is we want to see that we're actually changing these tags outside of just what the MikroTik configuration says. And so you look in the packet capture and you see I'm coming from my laptop number 1 here on, where's my IP? On 201. And I've got a VLAN ID of 101. I'm sorry, 200. You're coming from as your source and your destination is 201. And I've got a VLAN ID of 101. Well, then I come back to my return traffic as the ping makes its way from the second laptop back to the first, and it's sourced from 201 back to 101, and you can see the VLAN tag has actually changed to 201. So using that validation of Wireshark, you can actually watch your traffic translate. So let's get to a bridging example. We've done the CRS switching. You've already seen a little bit of an example of the bridging because of what we did to set up the maps. And so when you look at this, it's no different than an untagged port, and it's actually extremely easy. You literally take one VLAN interface and create it, and create your rewrite interface. So in this case, we're going to go from VLAN 500 to 3500, and then you put them in a bridge, and that's it. So you can literally translate between those two. And so the only, and we'll get into the why, which one you want to use in which case, but if you want to do this at the edge, say you're a service provider and you have to hand off layer 2, and you, for some reason, have a need to rewrite, then you could put this into 2011, or you could even do it in a map if you wanted to. So here's what a bridging config would look like. We've got a 2011 up here that's doing the bridging of the ports. You've got the maps in VLAN 500 interface, and then untagged your laptop, just like the CRS, going into ETH1, and then coming into ETH2, we've got VLAN 3500 out of the map here, and you've got the untagged port down here, and then we used a little different subnet here. The 100.64.1.1 and 164.1.2. And then these two were also able to ping each other because the bridge takes the traffic in, punts it up to the CPU takes care of the VLAN rewrite, and then it rewrites the frame out to the other port and does it in both directions for you. So this is a very easy way to do it. So when do you want to use switching versus bridging? What's the difference? Well, in the switch, obviously, the big advantage is that you've got ASICs on there. You've got wire speed chips that can get the traffic to full rate if it's a gigabit port. And so obviously, if latency is a concern, you're using this in a data center or in a core, somewhere where you really don't have to worry about CPU, then you're probably going to want to do it in a CRS just because it's going to happen at wire speed. And even if you have a high horsepower CCR, you probably will see some spikes of latency from time to time because that traffic still has to make its way up the CPU. So the switching is always going to be just a little bit faster. And so some of the applications that we would probably consider using the CRS switches for would be like data center interconnects. Anything in the service provider world, we'd probably put a CRS out there for. If you're a WISP and you're core layer and you want to try this, I think we would probably look at a CRS. There's no reason you can't do it in a CCR. If it works for you and you need to do it in a CCR, you can certainly do that. But if you have the choice, I'd probably do it in a CRS. And then you can use the routers for lower speed scenarios like something you use at the edge. So I want to go over a couple things before I get to any questions. We've got a couple giveaways at our booth. If you guys are not familiar with Google Cardboard virtual reality headsets, we're giving away 4 of them over the next 2 days. It's like a true immersive virtual reality experience. It's pretty cool. If you've never looked at Google Cardboard project, I suggest you check it out, and you can come by and register for one of these. And then we're also giving away 4 RC quadcopters. So we'll have 4 giveaways each day of the MUM, and wrapping up with the giveaway at the end of the MUM. So getting into that, I want to open it up for any questions. We'll post the content of the presentation at iparchitects.com. I've got my contact information on here. You can come see me and get a business card. We've got contact information on the website as well. And definitely want to thank you for your time, for attending the presentation, and definitely enjoy the MUM. And I'll open it up for questions now. Yes, sir. I looked in the switch chip when I was doing this, and I didn't see any config that would readily let you actually rewrite a VLAN. There was a Q&Q feature there, and I could talk to the MikroTik guys to see if it could even be done. But as far as I know, I don't believe it can be done on the switching chips in the routers. I'm sorry? Yeah, it's a little bit different switch chip, a little bit different architecture. It may be able to be done. I just don't know if the software commands are there to do it. All right, any other questions? Okay, thank you for your time.